Okay, hello everybody, I am Julia. I'm at the University of Colorado Boulder. I know some of you, and I apologize, this is going to be some review. I'm going to try to point out at least the things that have changed over the last year. So there have been a few updates. We keep kind of tweaking the schema a little bit here and there. So I have been working with these meaning representations for a while now. I started working for Martha Palmer in 2009 when I was working on my master's degree at CU, and I've had the opportunity to keep working for her in her lab ever since. And I finally started the PhD program 5 years ago, so that's where I am now. I'm not quite done with it yet, but hoping to be done soon. So I've been working on PropBank and BirdNet since very early days. PropBank, it was only verb role sets at that point. I've been with AMR almost since the very beginning. I made a spatial AMR adaptation, so spatial relations are a special interest of mine. And I'm one of those linguists with a funny background because I started out in fine arts. But I don't know, I've figured out over the years that meaning representations are art, and the art that I like to make was also meaning representation. So it does kind of feel like I've been doing a continuous thing all the way along. And this is my daughter. She's here on this trip with me. She's not here today, but she might pop in at some point. So, okay. So, oh my gosh, this is really small. So just to start really basic, symbolic meaning representations in general. So what is the main point of them? The thing that we do with them that we talk about most is try to make the meaning of a sentence or language parsable by a machine. They're centered on propositions, so we're talking about events, event states, things that happen, who did what to whom, when, where, and how. We're applying linguistic semantic analysis to the language training data that we're creating. So that means that it's different than like a black box kind of system. We're actually applying labels that we as humans have decided are important. And that's what it is. The roots are in formal logic, so the formats that we use are very logical, have like a kind of a mathematical basis. And semantics has been a very hard problem to solve for machine learning, and it is still hard to solve, even in spite of what you might think now. And this is one of my favorite quotes from Martha. You can't be a pessimist and work in semantics, because you really can't. And the other thing that I want to just start out talking about, I know every paper that any of us write now starts with like, oh, LLMs, but I'm going to do it too. So yes, they're great, and a lot of people are wondering, what are we still doing here? Have we solved this problem of parsing language and creating nice generative systems? And we have done a lot of that, but there are still a lot of places that semantic annotation continues to be really important. First of all, pre-training and fine-tuning language models for special domains, medical fields, what have you. It's still really helpful to be able to add human judgments into that. Another thing is that LLMs are great at language production, but they are not yet really good at language analysis, or they keep getting better at it, but it's still not even clear quite how good they are at it. I know there's so much work being done right now probing what they can and can't do. They still struggle with understanding constructions. We had a paper, it was GPT 3.5, so it's out of date and I haven't rerun it recently, but just trying to get ChatGPT to do basic semantic role labeling. It actually did a terrible job at it. And it might be that it was just not trained enough in the PropBank style annotation itself. But we're not yet at a point where if you want semantic annotation as an output, something parsable in that way, we're not yet at a point where we're getting LLMs to do that for us. So we're still important. We will continue to be important. Multimodal applications. There is so much more that we can do currently with annotation schemas where we can figure out how we want to incorporate multimodal data, because the LLMs aren't there yet. And then a big area of interest for me, I work on Arapaho with Andy Cowell. So low resource language settings, especially endangered languages, there are a lot of reasons that symbolic meaning representations are a better way to go for machine learning. If language communities want to participate in AI with their languages, there are issues of the training data being scarce. So our models do better on smaller data sets. You can't train an LLM on Arapaho, there isn't enough data. But furthermore, when you have more rule-based systems, you have more control over the output. So if you're dealing with a severely endangered language and you're worried that you're going to generate output that might not actually be true to the language, we in our systems have a bit more control over making sure that the output is actually reliable. And then, of course, there's the issue of ownership of the language data. So as soon as you feed things into the big AI machine, it's hard to get it back. So anyway, lots of reasons for still relevant. Oh, and then some of my favorites. Okay, so I don't hear a lot of conversation about this actually, but working with Arapaho, I just see so much value in these resources that we're creating just from a language documentation standpoint. Machine learning is great. It's cool that we can help that. But when I'm looking at an IGT, interlinearized loss, of a document for Arapaho, I'm not getting everything that I need to actually understand the sentence from that. I have to also have the grammar of the language with me to understand how to put the different phrases together. And the meaning representations, if I have an AMR graph, it tells me so much more about how the participants are interacting with the event. And creating valency lexicons. I don't know why we don't have more valency lexicons just across the board. I guess I've been working with semantic rules for too long, but it just feels like really interesting and important information to have about a language, even for English. Who the participants are and how core they are to the event. So I'm going to start, before we get into AMR or UMR or any of our particular family, I just want to talk a little bit about what some of the biggest design questions that symbolic meaning representations in general have to answer. And we just wrote a paper together, it isn't out yet, the UMR team, on different symbolic meaning representations, kind of a survey of them. But there are a whole bunch of different styles. So there are different ways that you can go about trying to encode the meaning of a sentence in a machine parsable way. So the first is the format. Do you want to have a flat representation? Do you want to have a box representation, or a tree, or a graph like AMR? All of this started with roots in formal logic. So that's a different way to go. There are questions about how important it is to have your output be human readable. I mean, it's great for it to be computer readable, but it's nice to also be able to look at the box and have it be kind of intuitive. The predicates and arguments and the relations. So when you have propositions, so somebody doing something to something else, or in a temporal span, in your representation, where are the concepts in your representation coming from? Are they coming from words in a sentence? Are those words in a sentence modified in some way, like normalized in some way? Are you using semantic primitives? If you have a set of semantic primitives that you're using, is it adequate? What are the categories that you've created? How informative is that set of primitives going to be? Is it going to accommodate different languages? And this issue, so what's a word? This is a huge thing that I run into a lot working with multi-word expressions in English, and then also Arapaho, which is a polysynthetic and agglutinating language. We kind of have this idea, because so many of these representations have started with English, that you're taking words from the sentence and you're plugging them into places in your representation, and you're putting relations between them. But sometimes your semantic concepts don't align with the concepts of words in the language from like a white space perspective. So if you're taking elements from the sentence, how are you allowed to break words down and put them into the representation as separate parts? Can you take a single morpheme and have it be a single chunk in your graph or whatever? How far can you break words down, and how many words can you clump together and put into a single node? And then if you're doing that, what kind of alignment do you have between your source sentence and the representation elements that you created? Some representations do have alignments and some don't. Like AMR does not, your UMR does. But obviously, the more you break things down and clump things together, the more important it is to start to have alignments. And then, in terms of the semantic scope and expressivity, do you deal with quantification? Do you deal with negation? Do you deal with scope? Some representations do and some don't. Do you have tense represented? Do you have aspect, modality, co-reference, named entities? A lot of times named entities are dealt with in combination with a specific ontology of types of things in the world. So are you using some kind of ontology like that? What ontology are you using? And then implicit information. How much are you allowed to infer about what's going on in the situation beyond what has actually been expressed explicitly in the sentence? What's the last thing? Oh yeah, lexical resources. Okay, so a huge thing with symbolic meaning representations is that so many of them are a two-part system. So you've got a lexicon that provides definitions, sense disambiguation, frame semantics for the event, participant labels. Some representations do use a lexical resource like that, and some don't. So if you're going to use a lexical resource, what is it, and how is it structured? And how have you drawn the line between the meaning of a word, like what do you allow to just be defined through the lexicon, and what do you actually have to put into your representation, into your graph? And last but not least, so many meaning representations have been based on English or other very frequently spoken languages, which tend to be similar to each other. They tend to be analytic languages, not polysynthetic. How broadly can your schema be applied? What we find is that systems trained on meaning representations for English don't do as well for other languages. So, and is that important to you or not? Or are you just working on a single language and it doesn't matter? And multimodality, we already said a little bit about this, but there's so much information that is pragmatic that you could choose to incorporate into your representation. Do you want to incorporate some link to gestures that people make? Do you want to incorporate documentation of spatial frame of reference? And then, so the idea is that we have these semantic representations. That's what we're going for. But it's virtually impossible to make a semantic representation that is just semantic. You end up with syntax bleeding into it. So how do you put bounds on your semantic representation? How much syntax do you allow to bleed into it? And how much pragmatics do you allow to bleed into it? And so on. So just as, I'm not going to explain all these, but these are some of the most common meaning representations. So early ones, minimal recursion semantics. So this is both of these and discourse representation structure. They both have a first order logic format. Actually, that one's first order logic. This one is just flat logic. And they both have a box notation. So like, for example, this one, you've got two different parts. You've got these variables, and you've got these relations. And then your constraints down here tell you how how these variables relate to each other. Basically, you have this flat representation up here, and these numbers will turn it into a tree for you. I find this very hard to read. And there are some things that each of these representations is better at than others. Discourse relation structure, they do more with tense, they do more, well, in some, you can incorporate tense. They do more with scope, so you have these scopal operators, but it's still a box. And I've highlighted here, so I think purple are concepts that don't come directly from the sentence, and blue are concepts that do come directly from the sentence. So you kind of get an idea of how much each of these representations is taking directly from the sentence. And like here, so you'll notice that fished, that's not normalized, it's just, it's an inflected verb. They haven't normalized it at all. But like, no, I guess this one doesn't really show. Okay, so those are that's just two different options. Here's ACA, Universal Conceptual Cognitive Annotation. So this one is pretty minimal. The relations are just these variables. There are very few of them. So it's not a really semantically expressive system. And also these words are not normalized at all. So they're just all directly taken from the sentence. Here's the product dependency tree bank. Jan, if anybody has questions about it, Jan could describe it more. It is also tree structured. There are layers of different layers of relations. And then two other, a different kind of representation. VerbNet and FrameNet both are more about the ontology. Each of them does have an annotation system of sorts, but neither of these representations actually aims to capture the meaning of an entire sentence. They're really just about a single proposition at a time. But they're both about the semantic frame, what is the event that's occurring for the participants. VerbNet is a marriage of semantics and syntax, whereas FrameNet is much more purely semantic. And then last but not least, we've got AMR and UMR. So here we have rooted directed acyclic graphs, DAGs. This is the Penman notation style. And you can see that they're basically the same structure as each other. Everything here is a document level graph that does cross-document relations. Everything in pink here is what is different from the AMR version. So the advantage of a graph like this, even though they're rooted with a single node at the top, I don't think I have inverse relations in here, but basically there are different ways.
There are two.
Are there?
Arguing.
Oh yeah, arg1 up, yes. Yes, okay, Sam Fish with the rod his grandfather had given him. So you could rearrange this graph and have give up at the top. Really, you could rearrange it and have any node at the top because you have these inverse relations. You can just reorganize things. And they would be logically equivalent.
Excuse me.
Mm-hmm.
Sorry. Can I ask a question?
Of course, yes.
So when you say that, anyway, I'm showing. So when you say you can reorganize the graph, but still you would start with your root is always fixed, right? Or there is no concept of root.
The root is what you choose to put at the top. And some people will argue that there's really one root that you should have.
And so if we talk about the graph, yeah, you can make any, you have to have a starting point. But as theoretically, do you consider the main verb to be the root or head of the sentence?
The way I would make a graph, I would always make the main predication the top node. And if you just have like a noun phrase, for instance, I would probably have that noun be the top node with everything else cascading down below it. But if you were to rearrange your graph in any way, you would still consider it to be logically equivalent, no matter what was at the top. So it's logically equivalent, but there is still a pragmatic choice.
Computationally
Can I,
also
I'm
need
so-
a.
I'm sorry, can I just elaborate just a little
Yes.
bit? So, it's a great question that I think might be addressed on Thursday when we talk about some of the statistics. So as Julia said, they're logically equivalent, but, and you're correct, in a graph theoretic interpretation, you can rearrange and get bisimulated graph interpretations, right? What we're moving towards, we don't know because we're a committee, right, is pointed graph interpretations. So that is, you have a pointed interpretation from the node, which would be the root, which would actually semantically or pragmatically be distinct from the other one. So the rod, so the grandfather gave Sam the thing he fished with is very different from a pragmatic or discourse perspective. So we'll get to some of that on Thursday.
Yeah. Yeah, and it's actually really interesting because that's something that I feel like is shifting from AMR. This principle was developed with AMR in mind, where you're really trying to get away from the syntax and the choice of morphosyntactic expression and all of those
Yeah.
pragmatic issues.
Yeah,
And-
the Penman notation in AMR does not even have a vocabulary for such distinctions. It never intended to.
Yeah.
It was out of the purview. But as Julie said, UMR is a broader scope to try to incorporate those types of meanings.
And part of that is that AMR, when it started, was just one sentence at a time. You weren't looking at all the sentences together. I mean, you could kind of refer to them to get an idea of what was going on, but you weren't representing discourse structure at all. But UMR, because we do document level annotation, you do pay attention to that stuff more. So, yeah. Okay, so now I'm going to narrow in on just this family of symbolic representations. So I'm going to start with one slide on tree bank, prop bank, AMR, and then UMR, because they all just kind of fed into each other. So in the mid-90s, we finally got good at syntactic parsing. So the Penn tree bank was very significant. It would generate these lovely syntax trees. It looked like this. So Martha Palmer decided, hey, we can use these syntax trees as a scaffolding to finally try to work on semantic parsing. And so here you've got a tree bank, syntax tree, and then she said, okay, so what are we going to get at? We're going to get at propositions, one verb at a time. We're going to make a role set. It's going to have the verb, and it's going to have a set of numbered arguments for the participants that are central to this event. And we're going to lay those labels on top of the tree bank tree. And if your sentence is longer and it has multiple verbs, you don't worry about it when you're annotating. You just do one verb at a time, and then post-processing, they sandwich them all together into a representation that actually does cover the whole sentence. So that worked really well. Prop bank was really successful. It showed people that you could kind of do this at a large scale, semantic role labeling. And then in the early 2010s, people started to say, hey, this is really, we have a lot of syntax wrapped up in this still. What if we did it differently, we got rid of the syntax tree, and we just used these role sets to actually create the structure of the tree? And so this is when Martha got together with Kevin Knight and some other folks and created a modern AMR. So you can see, I mean, the AMR graph is quite similar to the syntax tree, but it's not exactly the same. And one advantage, the syntax trees, they have all of these pro arguments, so you'd be labeling these all the time. In AMR, you don't even have to label those things. They can get filled in automatically later in your implicit arguments, but you don't have to do it. That is interesting. Okay, I know what I did. Okay, I think this slide is not working. No, there it is. Oh no. Okay, I'm going to tell you what's going to happen. So I changed this sentence because I didn't like it anymore. I changed it to when John met Mary on Thursday, they discussed the return of the garden tools, but I didn't do all the layers in the slide, so it's gonna switch. So we'll just start with this. Actually, I'm just gonna fill all this in. Nope. There we go. Okay, so we have a proposition. John met Mary. There are also different ways that you can express this same meeting. John and Mary met. John met with Mary. John and Mary had a meeting, light verb construction. The proposition is just the semantic notion of what is going on. You can represent it with this predicate logic kind of format. You've got a predicate, you've got two participants, John and Mary. Somebody one and somebody two. So they're the meters. My red arrows have gone away, but yeah, I guess that's. So that's the first part. You've got propositions. And then the other part is you have semantic roles, and it's really important to distinguish them from syntactic roles. So in this example, Tim broke the window. You have Tim, who's an agent, who's also the subject. You have a window, who's the patient. It's the direct object. In this example, the window was broken by the hurricane. The window is still a patient, even though it's moved into subject position. So when we're creating role sets, when we're doing semantic role labeling, we're getting at this, we're not getting at the grammatical roles. So here's an example of a role set. The prop bank frame files, which I've probably made more of them than anybody at this point, maybe even more than Paul Kingsbury, who was the first maker. I've been working on them for 16, 17 years, what is it now? They've changed a lot over the years. Now, it used to be just verbs, but now we include aliases, different morphosyntactic expressions of the same event. So discuss, discussion, the noun, have discussion, like verb construction, they're all clustered together under this single role set label. So role set labels always have a lemma form that you've chosen and a number, and the numbers are sense disambiguating. So I don't think there are a lot of different senses of discuss, but this is the talk about sense. And you've got 3 numbered arguments, the discussant, the person doing the discussing, the topic, and the conversation partner. Prop bank includes these little function tags, so these are kind of like, they're little semantic roles. They don't show up in the AMR graphs or the UMR graphs, but you can always look at prop bank and see what they are. The reason that prop bank uses numbered arguments is because you actually still are kind of splitting the difference between the syntactic, the grammatical role, and the semantic role. So the entity that is the subject in active constructions is almost always the first numbered argument. So the agent is usually first. If it's a property, the thing that has the property is probably first. But there's not a specific semantic role that is tied to this number. So they are, I think arg0 is the only one that actually is pretty tied to actor or agent. But the other ones can really be anything. This is intuitive, but so this is representing the proposition as a tree. You have John and Mary over here discussing the main verb is at the top, and the return of the garden tools is the other argument. Applying the numbered argument labels to these edges. So John and Mary are at arg0, etc. And then here we have, even though it's not mentioned explicitly in the sentence, we can infer that there is this argument here. So we are aware that somebody is doing the returning of the tools, even though we don't know who that person is. It might be Mary. So this is just prop bank annotation. So prop bank had its own annotation schema. You used these generic roles. They were very, very coarse-grained, location, direction, cause, manner, etc. for general semantic arguments and these. And then this is what the actual annotation format looked like. So the Connell format, also not very easy to read. Not fun to read, at least, but still effective. So then AMR started. The thing about AMR is the format already existed. So it was a notation, but there was no training data. There was no annotated corpus, and it didn't use the prop bank rule sets originally. But when Martha and Kevin Knight and all of these folks got together, they teamed up and they applied the prop bank rule sets, and they worked on making a big, giant corpus. So it was really successful at proving that like larger scales in banking is possible. I think the 3.0 release, it's just the 3.0 release, has about 60,000 sentences for English. Chinese AMR has more than 20,000 sentences. It's probably much more than this now because so many different people are doing it, but that's just the LDC release. Okay, so everything that comes now is about the Penman notation. Actually, no, we're not quite to Penman notation. Okay, this is just, okay, sorry, I got ahead of myself. This is a major change from prop bank to AMR. So prop bank, you actually just noted the span. So you'd like tokenize the words in the sentence, and then the actual annotation itself just told you what the span of each argument was. With AMR, it's not spans anymore. It's just concept. So you're breaking each of these phrases up and getting more detailed annotation for it. Is that good? Okay. Okay, this is Penman notation. Okay. So the little cat likes to eat cheese. The building blocks are the concepts from the sentence. So we've got the roll set label, like 01. We've got cat, little, a roll set label for eat 01, and cheese. So those are all of our concepts. We've got a variable for each of the concepts, and the variables can be used, hold on, I'm jumping ahead. They can be re-entered later in the graph. So if you have two mentions of the cat, you use the variable farther down in the graph, and that helps keep the graph with a single root. The edges are these relations that are marked with a colon. We have numbered arguments from the prop bank rule sets, and then we also have general semantic arguments. And UMR's inventory is a little bit larger than AMR's. And AMR's was a little bit larger than prop bank's. So we keep getting a little bit more fine-grained with our general semantic rules. We have these inverses, which we mentioned before. These also help keep your graph having a single root. But like I said, I mean, you could have this up at the top and have two roots and have it just say arc 0 pointing down to cat, and it would be logically equivalent. And here are the slides on the top node issue. So, like we already said, this is an example of how you would rearrange the graph depending on what you want your top node to be. So cats eat cheese. Preferably, you would have eat be the top node of your graph, like this. Cats that eat cheese, because this is actually a noun phrase, you would preferably have cat at the top. Named entities. Okay, AMR does fun things with named entities. So, sorry, this is very small. Yeah, okay, so AMR has an inventory of about 70 named entity types. So the named entity types, they're just a general, generic, abstract concept. The idea is you can fit anything in the world into one of these categories, these 70 categories. It's a hierarchy, so you start with that as your head node, and then you add the actual name. So the reason to do it this way is that Grumpy and Cat are not nested. Like they're, well, I guess they kind of are. But if it was John Smith, they would be nested, you know. So there's just it's a good way to show that there's a flat relationship between the two words in the name. There's also a wiki role. We haven't actually talked about whether we do this for UMR,
Yeah, we haven't
but it's in a lot of the data. It's in the 2.0 release just because it's in there from the English AMR that we've been converting from. So you'll see it in the data, but yeah, it's just a link to the Wikipedia page where that entity exists. Okay, so here's a little review. The dog ate the 4 bones it found. You've got the concepts in purple that come from the sentence. You've got the variables for each of them. For English, the variables tend to be the first letter of the word. With UMR, it gets interesting because you have different characters from different languages. Some, like Chinese, you use
some generated name,
like X or
something.
yeah. With Arapaho, we have some numerals, like the letter 3, the number 3 is a sound, so we use an X for that. But yeah, variables, the edges. Constants, I mentioned this before. So most concepts are in parentheses, but you have a certain special kind that are constants that aren't in quotation marks, that are not in parentheses, they're just independent. It's constant. Inverse roles, and reentrancy. Any questions about the general format of Penman? No. Okay.
I have another question. Sorry if I may. I came a little bit late, maybe that's why I missed this question, but we don't have the slides, am I right? Because
Not yet.
not okay. Then
Yeah.
that's enough. That's because I thought that maybe I missed already. That's why I'm doing always the screenshots.
No, I'll put them up.
I'm following from last year's.
Oh, okay. It's slightly different. I rearranged them.
I do that.
Okay, no, it's okay. Thank you so much. Because we get this Google Share Drive.
Oh.
I mean, for our group,
Okay.
and there's
Nothing in
at least for me it's empty.
Okay.
And I was a little bit, how can I say, am I missing anything?
Right. Yes, I would think that too. I think we just don't have our wires connected yet.
Yeah, so we need to update that.
But we'll get that figured out today.
No,
For
thank
the
you so
slide.
much. In this case, I shouldn't worry about the screenshots. Thank you.
And you had questions?
Do you have only one kind of edge, in the sense like all these edge are kind of dependency relations? Or do you, like, for example, if you go back to that named entity, you had Grumpy and Cat. They're also,
Okay.
so here this op1 and op2. So this name is a kind of, no, so arg0, arg1, these are edge, these are dependency. What about this name and wiki? They are not dependency, right?
They actually are. We could have formatted it that way. I just didn't because it
No,
takes a lot of
format
space.
is fine, but semantically they are not dependents. They are not marking the edge for head dependent.
They, I mean, I don't know. Do you have a better way to explain this?
What's the question again? It's the semantic interpretation of op1 and op2?
Yeah, are they actually dependencies related to the name concept?
No, they're not native to name, right? Op1 and 2 will be for anything that allows for kind of the integration or conjunction.
Yeah, but this green, I don't know, this color, what is this name, colon name? Yes,
Yeah, so that's that's an edge.
that's an edge.
And
but
then
that
this is its parent
But
node.
that edge is not a dependency edge.
This one?
Huh.
It's not a dependency to animal?
Name, do you consider? No,
This one?
yes, because see, arg0 is an edge name that connects head and dependent. Like is the head and animal is the dependent. Arg0 is the edge level for the dependency. Now I come inside arg0, there is name, and then this is an edge as you were saying. Now it is connecting animal and whatever is there inside. Now is that relation is not a dependency relation, right?
I think maybe part of the confusion is that you have an edge, which is the same name as the actual node. which is
So I'm asking whether We have different kinds of it.
Different kinds of edges.
Well, I think there are different kinds of edges, right? So some of them non-semantic rows.
Some of them are not dependency.
They're just attributes.
They are
Right.
attributes.
Yes, okay,
Yeah.
yes, some are just attributes.
Yeah, that's a weird, construct because when
Yeah.
I first saw it, it's like, okay, you have a name, relation, then you have a name.
Because when we are formally interpreting
Mhm.
grammar, then all these questions will come, right? Like what is the formal interpretation of these edges?
Mhm.
So RDF triples, which is where Penman comes from back in the day, essentially is just a three, it's a three triple, right? So, and you can have an attribute structure which essentially it tells you your animal's name is Grumpy, or
Yeah,
whatever.
so, yeah.
Or it can actually be relation, so, which is something for object, right? So, as you know. So yes, the original interpretation of attributes as an RDF triple, from a semantics point of view, has always been the bane of RDF semantics. And formal semanticists have never particularly been fond of that. However, now, everyone's totally fine with it because they're knowledge graphs. And they're totally usable as something which is directly digestible by embeddings and RAG and things like that. So formal semanticists who are now computational will go, yay, this is great. So hindsight is golden. So, but you're right to point this out. But it's an attribute for all intents and purposes.
It's an attribute.
Yeah.
Yes, I think the edges just have a collection of different things, right? So you have this X0 and so that's from a lexicon, and you have relations like temporal and stuff, right? So it's not from lexicon, it's just like a list of things. And you have these a name, and that's more like an attribute, right? It's not interpretable as something that's massive.
I'm curious about the effectiveness of Wiki and UMR because it's for a lot of low resource languages. So I'm curious if Arapaho would have Wiki pages dedicated to it. So would Wiki be excluded for those languages? Is it?
Yeah,
Just
it's not a mandatory role at all. It's if your project is, in a language that has a Wikipedia and it's useful for clustering together identity relations, like instances. But yeah, you don't have to include it. Okay.
Sorry, I didn't catch it. You have mentioned it, but the first letter, using the first letter, how does it work for the language like Chinese? You mentioned it, but I didn't.
Yeah, so for a language like Chinese, they would use X or some other
It's
code.
actually X with index.
X with,
Index and Chinese MR because I'm doing that.
yeah. Yeah, so you kind of have to decide for your language what the best solution is.
The attributes that you have are only for name entities, or we can have attributes for other types?
There are attributes for other types too, so we'll get to the full list in a second.
And so if we have something like John likes Grumpy Cat, we would have the attribute inside the dependency relation.
Which attribute?
The one name, Grumpy, like you have it.
Yeah.
So we have it in arg1,
Yeah.
and then another node with the attribute.
If it was John likes Grumpy Cat, you would.
The attribute there, sorry to interrupt you, Julia, just to clarify, stays within the modification relationship of the entity it is modifying. So in that case, it would look exactly like this. It would be arg1. You'd have animal, name would be the attribute subordinated by A.
Okay.
Okay, but as Julia was alluding to, if you had very much likes Grumpy Cat or some sort of modality or aspect, that would be a mod, which would be an attribute relationship on the verb itself.
Oh, okay.
Yeah.
And she'll get to that in detail.
Okay, thank you.
Okay. We did that. Okay, so this is still, we're still talking about AMR, but we're also covering almost all the things that I'm going to talk about apply to UMR too, because UMR is built on this base that is very much like AMR. So these are basic annotation philosophies. Limited normalization. So this is where you kind of pick a lemma form for your concepts. The idea is to get rid of as much of that syntax layer as possible and just boil everything down to the semantics. It's not a syntactic sugar is the way it's been described. Everything that is predicating, at this point we make a prop bank rule set for it. So we have prop bank rule sets now for predicating nouns and adjectives and even predicating prepositional phrases, like verb constructions, other kinds of constructions, schematic constructions, idioms. They can all have an individual rule set. So if it's predicating, you want to use a rule set. Oh, and I didn't say about there's a little bit of morphological decomposition that AMR allowed. UMR allows more, it turns out. But for instance, if you had, all the examples I can ever think of are like horrible. I need a negative. Why am I so bad at examples?
What are you looking
The pain was intolerable. The pain was intolerable. You can break down the word intolerable. You can get rid of the negative. You just have tolerable be the rule set, and then you have a negative polarity under it. So AMR let you break down that much, but not really beyond that. Limited speculation. So in AMR, you could infer a bit about what was going on beyond what was explicitly stated. Like if you had the cat likes to eat cheese, I mean, obviously the eating cheese event is being done by the cat. The cat doesn't like for someone else to eat cheese. You could put the cat down as the liker of, you put the cat down as the liker and as the eater of the cheese. But it was very limited, so you could do some kinds of inference. You didn't want to really make inferences across sentence boundaries, though, because the parser was going to have a hard time. If the parser wasn't looking at the next sentence, it would have no idea where these hallucinated concepts had come from. So only things that could be done consistently and understood by the parser. Canonicalize the rest. So things like semantically light predicates, like in light verb constructions, if you have John took a bath, you can just leave that take verb out of the graph. You don't have to put it in there. The main predicate would be bathe or bath. Okay, so you can generalize across parts of speech for etymologically related words, and that's a crucial point. So my fear of snakes, I am fearful of snakes, I fear snakes, I'm afraid of snakes. These are all etymologically related. They can be clustered under the same rule set label. But synonyms you don't generalize over. So my fear of snakes, I'm terrified of snakes, snakes creep me out. You would not put those under the same rule set label. They're their own rule sets. Okay, so we're going to talk more about this tomorrow. But multi-word expressions and morphologically complex words are complicated. Especially as you get into lower resource languages, polysynthetic languages, but they're also complicated in English too. But basically, AMR would let you cluster multi-word expressions together. Line pockets, that can be, and it's one semantic concept, so you can put it in one node. Other just flat multi-word expressions, like by and large, you can have that be a single node just with hyphens. There are some words that AMR let you break down that were more logically complex, so like investments, when you're talking about the actual thing that was invested, you wouldn't just have the rule set for invest, because that's referring to the event itself. You would actually extract that there's this thing that's been invested, and that's what you're talking about. You're talking about the thing, not the act. So you have multiple nodes in the graph that point back to that same word. And then this is something that only AMR did. We've gotten away from this in UMR. But in AMR, everything was normalized so that it was singular, it was nominative, a cat, the cat. You didn't mark definiteness, you didn't mark plurality. inflection was pulled off of verbs. That, oh, and I'll go back. So that is done, we do plurality now in UMR. We still normalize verbs if you want to for your language. You also have the option at different stages of annotation not to worry about that part yet. So you actually can do a fully inflected verb in UMR. Okay, and then just to kind of sum all this up, so the normalization, all 4 of these sentences would be represented by the same graph. The man described the mission as a disaster. Everything that's in pink up there is kind of the syntactic sugar. So, and everything that's in the colors obviously just points back to individual nodes in the graph. Does that make sense? All of that? Any questions on any of that stuff? Okay, because now we have an example that we can try. Edmund Pope tasted freedom today for the first time in more than 8 months. Okay. So what do you think the first node is? Tasted. Main verb at the top. We have a role set for taste in English Pop Bank. There's an experiencer, arg 0, there's a stimulus, arg 1. So I'm going to have an AMR. Actually, it's going to be a UMR graph because they're slightly different. It's going to be UMR. And then a tree form over on the other side. Okay, so taste at the top. Now, what's the next thing we do? Add Edmund Pope, probably. So he's the arg 0. So he's a named entity. So we do the full thing like with Grumpy Cat. And then we have an arg 1. That's the stimulus. The freedom. He tasted freedom. There it is. We have a rule set for freedom. It has 3 arguments: the free entity, free from what, and free to do what. So the free entity, even though it doesn't say Edmund Pope tasted his own freedom, we can go ahead and fill that in because we know it's his own freedom. So there's a reentrancy. Okay, now we're on to the temporal phrase. So in AMR, this was actually time, but in UMR, it's temporal. Today, that one is its own node, just today. Now we have for the first time in more than 8 months. So this is a complicated one. How do you think we might do this? We have a role called ord for ordinals. It takes a subrole called value. When you annotate it, it looks like this. So you start with this as an abstract concept, kind of like how the person is an abstract concept. That's the named entity type. This is an entity type also. So the ordinal entity has a value of 1 because it's the first time. So ord also has a sub-role called range. So in more than 8 months, that's the span over which that ordinal holds. Oops, no, backwards. More than is a multi-word expression. In this case, we can just hyphenate it and put it in one node. So the range is more than 8 months. So 8 months is also interesting. 8 months we do with another abstract concept. This is called temporal quantity. It has a subrole of quant. So quant for 8, and then month is the unit. Does that make sense? Okay. AMR, just wrap up AMR. There have been a lot of expansions to AMR. AMR was really popular. It's still really popular. Most importantly for me, it is fun. It's easy. I mean, it's not easy. It feels easy now that I'm doing AMR. But it's fun. It's fun to do. It's also really useful, and because there was so much annotation with it, there was a really good, broad, general domain base of annotation that you could use for parsers that you design for more specific purposes. So multi-sentence AMR, really important, because UMR uses a lot of the schema from multi-sentence AMR. So multi-sentence AMR did co-reference annotations between entities and events and bridging relations like part-whole relationships. set member relationships. Yes, it was the first time that we did whole documents. Spatial AMR, super fine-grained spatial relationships, tracking spatial frame of reference. This project is done on the Minecraft dialog corpus, which is a multimodal grounded corpus in the Minecraft environment. And this data, a lot of this data, actually I think all of this data is being used for the UMR release. So we are going to go over some of the spatial schema today because it is actually showing up in the 2.0 release. Temporal AMR, fine-grained temporal relationships, dialogue AMR, as is clear by now, and gesture AMR, which James could tell everything about. Yeah, so lots, and these are not the only things. There are other adaptations too, but those are the ones that I'm most familiar with. Cross-lingual AMR adaptations, there are a lot of them. If you have any questions about this, ask Shira. Yeah, so this is kind of why UMR exists. AMR was never intended to be used for languages other than English. It was built for English with English semantics in mind. But because it was so effective and popular, people started adapting it, but everybody's adapting it in their own way. And the farther another language is from English, psychologically speaking, the farther the annotation style is. So it's just getting all inconsistent. You can't put these data sets together, and you can kind of, but it was getting messy. So, but there have been a lot of adaptations done for the languages. These are the ones Shira and I, mostly Shira, wrote a paper about these adaptations. So these are the ones that we wrote about in the paper. Yeah, Chinese, Spanish, Portuguese, Vietnamese, Korean, Turkish, Persian. This was a couple years ago. There are more than that now. Okay, do we need to do a break before we start the UMR schema?
We will have a break at 11:20.
11:20? Is the coffee not here yet?
It's a first.
Oh, okay. I mean, it's like a natural break point, but I can go ahead and start.
You wanna, okay.
Well, I mean, what? I don't know. What do people think? Do you want to take a break now, or do you want to? All right, let's just stick with the plan then.
Okay.
Because it would be really horrible to get over there and have there not be coffee. So.
There is coffee.
Oh, it is over there already. Oh, okay.
Michael set it up.
Okay, good deal. Okay, so UMR, the goal of UMR was kind of to do all of the things that the AMR adaptations were doing uniformly and while accounting for typological diversity. I mean, there's more to it than that too. We wanted it to be more semantically expressive, and we got into some new stuff, but that's the overall gist. So it's AMR-like in the base, plus we've added aspects, tense, modality. We have an expanded quantification and scope system. We have very expanded discourse relations. We had Bill Croft and his team at University of New Mexico who did a lot of the schema design work. It's been great to have a typologist. We also have field linguists who specialize in a bunch of non-Western languages who've been helping, trying to make this schema more cross-linguistically applicable and sensitive. So there were semantic category shifts that needed to happen. They revamped the categories for the semantic roles to reflect the roles that appear. They did a huge survey on roles that appear more commonly across languages. This lattice system, so basically, instead of having a single flat set of semantic primitives for like your aspectual categories, and it's not even a tree, it's a lattice. Instead of having a single set or a hierarchy, you've got a whole bunch of types that are all related together in this lattice form. And really you can choose whatever suits your language within that lattice. But it means that rather than having everybody going off and doing their own thing for their adaptation for their language, everybody is operating within the same overall framework. And the framework is extensible too. So if it turns out that we need to keep expanding our lattices, we actually could do it. It helps keep everything uniform. We've expanded the named entity hierarchy. We've changed how we do pronouns. In AMR, what?
Sorry, how are the lattices extensible?
Well, for instance, pronouns, we decided this last year that it was weird trying to annotate generic pronouns, like one does not simply walk into Mordor. It felt weird to annotate that like a regular pronoun. So we added a refer definiteness attribute
Oh, interesting.
that you could apply to pronouns, so the value is class. So if it's a generic, it's refer definiteness class. And there's a slide on that later.
Okay.
We've also added a couple things to the aspect lattice. We added a generic type for aspect.
Okay, interesting. So you could keep adding kind of.
Yeah,
Okay, cool.
yeah. If you feel like you want to get more fine-grained somewhere, you could add another layer. If you need something that's more generic than two types, you could add a parent.
Thanks.
Oh wait, did I cover all that? Oh yeah, okay. Non-prototypical predication, so we'll go over that later, but that's cases where a language doesn't use like an actual verb for predication. Like some languages just use juxtaposition, two nouns next to each other to show predication, or even the copula counts. AMR did not have a rule set for B. We used a domain role for that relation. But so we've added these. That's also, I guess it's more of a hierarchy than a lattice, but yeah. So basically, there are just more granularity options in UMR than there were in AMR. And we have two annotation stages now with a big wide range. It's kind of a middle stage in between them. So you can annotate languages like English or Chinese that already have a big prop bank rule set lexicon, or you can annotate a language like Repo that does not have such a thing, and you can just use generic roles. But that really speeds things up because building a lexicon takes a lot of time. Document level graph. So this is probably the biggest thing that UMR adds. It's a second graph for every sentence that tracks cross-document relationships. So temporal relationships, co-reference relations, that's really similar to what was done in multi-sentence AMR, and then modal relations. So we'll go over all of that later. Token alignments, we also add, really important. It is such a pain in the butt that AMR does not have token alignments. But and then there's still things that we're working on. Of course, we are well underway working on the gesture annotation, spatial relations, like I mentioned. They have worked their way into the 2.0 release, but they're not fully converted yet. So those things some of them are still under discussion. Dialogue strategies. We don't have an extensive system of speech act annotation yet. However, a lot of us are annotating data sets that do have dialogues, and so we have some basic strategies for dealing with multiple speakers and basic speech acts. And then this is the thing, I'm really working on this a lot now. It's actually my dissertation work, figuring out how to update lexicon building for a cross-linguistically applicable meaning representation. Yeah, when you're annotating polysynthetic languages, figuring out how to normalize a verb that is actually an entire sentence, so that not only can different annotators do it consistently, but so that I can do it consistently with myself. It's really difficult. And this is what I mentioned about the annotation stages. Is there anything there that I didn't mention? Basically, I think the thing I didn't say is that if you start with stage 0 annotation, say you have a language like Arapaho, there's some amount of language documentation that's been done on it. Maybe there's a dictionary. There aren't rule sets. You can start annotation without the rule sets, but as you go, you're going to be probably working on building rule sets. So the goal, eventually, ideally, through using the UMR writer, there's a function that will help you build role sets as you go. Ideally, you will end up with an annotated corpus and a set of role sets in that. And that's stage one. But when you're in that in-between stage, it can be messy. So. Okay, and this is, we already saw this slide, but just once again, the differences between AMR and UMR. All right, are we ready to get into the actual schema now? Okay. There's a lot. Anything that we don't get through today, we can finish up tomorrow morning. And definitely interrupt me if I'm going too fast or if I need to speed up. But yeah, please interrupt me with questions. The first thing I want to do is just lay out some terminology for the physical structures of the graphs. One of the things that drove me crazy when I started this project is that we use so many of the same words for the same thing, for different things. I think there was one sentence in the guidelines that used the word predicate or some variation on it 3 times, and it meant 3 different things. And I was like, I can't understand this. Okay, so graph concepts, these are the physical forms that we actually put into the graph. We're not talking about the referent, we're just talking about the actual graph structure. So basic concept is going to be like this. It has a variable, it's in parentheses, and that's it. It might be a word in the sentence, it might be an abstract concept from the UMR schema. Role set ID or predicate label if you don't have role sets. So that's a stage 1 term, that's a stage 2 term, stage 0. It's like a basic concept except it has a 2-digit or maybe 3-digit suffix on the end. If you don't have the role sets, use a -00. Strings. Some kinds of roles take a string as their value. They're just in quotes. And constants, all of the attributes take a constant. Numerals are constants, and then things like for the aspectual annotation, the modal annotation, for each of those attributes there's like an inventory of possible values, and they're constants. So no parentheses, no quotation marks. The relations, the edges, same format as AMR. So structure-wise, they're the same. Content-wise, they're a little different. And then, before we get into the semantic roles, I just want to say explicitly, most of your graph is going to consist of words from the sentence, or normalized words from the sentence. Most of your predicates are going to be either like CAPTCHA1, like a role set, or COT, see it's still inflected, 0, 0. And most of your arguments are going to be things like fish, words from the sentence. What was I going to say about? I think I was just going to note, just note that whatever form you put in here when you're in stage 0, you can kind of choose how you're going to normalize it. Oh yeah, and there's fish. Okay, so AMR just had one kind of semantic relation. They were just the roles. UMR, we divide it into 3 different types. So we have participant roles. So these are the entities who are central to the event. In AMR, because we were using prop-bank role sets, we didn't need to have general semantic roles for things like agent or patient because they were always numbered arguments. In UMR, because we don't have to use role sets, we've had to add those. So those are participant roles. Non-participant roles are things that they're less central to the event. They can really be applied, they're like adverbials, they can be applied to any kind of event. And then attributes, these are the ones that take constants as their value, so aspect, polarity, mode, quant, degree, and then these are the ones that are used for pronouns. And the modal, but we'll talk about all of those. Those are the 3 types. Okay, so now this is what I've been doing recently. I just made all these reference pages, so we didn't have this a year ago. I'm really excited that these are finally up. So on the UMR website, which is umrfornlp.github.io, if you go to this menu here, this is the main page, UMR schema reference pages is under UMR tools. So it has like the full current lists. We have been in the process of redoing the UMR guidelines, and it's been a very slow process, and we have not been updating the guidelines because there's so much restructuring that needs to be done. Like, we haven't been updating what's formally posted, just because it would be really disruptive to keep making changes to it all the time. But there will be Guidelines 2.0 put out. In the meantime, though, this is where you can find the current lists of things that we've added to the schema, with definitions and examples. So now I want to open. Nope, that's not it. This one. Okay, I think I'm just gonna go off of here. Can you read this at all?
Like the small.
Yes.
Is it better?
Yeah. Okay, so this page has all the participant roles, and then if you roll over, there are examples. It has all the non-participant roles, and we'll go through them, but I'm just showing you what's on page. The spatial relations that you will see in the UMR 2.0 data, these are the ones that we've agreed to keep. So I think these are staying. And then the attribute roles. The only thing is the two attribute roles that have their own pages are aspect and modal strength. So those aren't on this page. Wait, is there another one? Oh yeah, and then the pronoun section is down here. So those are the pronoun lattices. All right, so let's just briefly go through the participant roles. And I don't know, I don't want to spend like a ton of time on each of these because it'll take forever, but since you can get to these lists, like please spend time with them. We have an actor, co-actor. So actor is basically like an agent. Anything that you would use agent for, you would use actor for. Co-actor, this one's new. So we agreed on this sometime in the last, 6 months. And it's for things like Jane's Battle of the Dragon. So where you've got, it's not really a companion, they're not doing it together. They're kind of doing it against each other, you know. Undergoer, so this is kind of the proto-patient kind of role. Oh, and then the last thing I should mention is each of these roles is listed with its inverse role and its reification. So we haven't talked about reification yet, but anything that's a relation can also be expressed in the UMR graph as a role set. So if A has a relation of undergoer to B, then A is the event and B is the undergoer. So, does that make sense? It's the same relationship. The reason that you might use a reified role set is if it's actually easier with some of the other roles, but like place is a really common one. So he read a book in the garden. This in the garden phrase, this is just an adverbial modifier. You probably wouldn't use have place as the top node there. But if your sentence was, he was in the garden, then the place relationship is actually what's being predicated there. So in that case, you would want to use have place. The other reason you might want to use a reification rule set is that it gives you a variable that you can then re-enter into the graph other places. So actor, co-actor, undergoer, theme. Theme gets used a lot. There was some disagreement originally that it was maybe supposed to be purely a motion, a thing in motion, but it's, yeah, it doesn't have to be a thing in motion. She told him a story. The story is going to be the theme. Yeah, and please go back and look at these graphs for examples. Recipient. So she told him a story. So recipients of communication events, also recipients of possession transfer events. So force, causer, and cause are related to each other. They're all things that kind of cause other events to occur. A force is going to be like a natural force, like the wind. The wind knocked down the tree. A causer, the way UMR uses causer, a lot of languages don't have an actual separate verb for the causation. They might have a morpheme for the causation. So if you have the mother made her child eat broccoli, if you have an English rule set, then you would just have a make. You would have a make predicate there, and the rule set would have an arg0 and an arg1. But if you didn't have that rule set, the person doing the making, that's the causer. And the person who's doing, wait, hold on, is it weird? I think it's weird. I think the person who is doing the eating would then be the actor. So I think the way that this should look is causer, and then actor, and then theme. Yeah, so the mother made her child eat the broccoli. The mother would be the causer, the child would be the actor, and the broccoli would be actually probably be an undergoer. Oh, is it time? Yes, it is time for coffee. Okay.
No.
All right, I'm gonna start.
And she was not. Just making sure.
Okay, I think we were in the middle of this list of roles. I don't know how much detail do we want to go into. All right, so is everybody fairly familiar with semantic roles? Okay. So I'll just kind of list what's left, and then everyone can kind of investigate the finer points on their own. Experience or stimulus. The one thing I'll note here is that we decided that rather than just having separate reification rule sets, we just have this one general reification rule set that serves both of them. Part of that, do I have an example? Part of that is because some languages have this argument, the experience itself. So we actually had already added this as an abstract rule set, just so we could have a numbered argument for the experience itself. Whereas in English, like the experience itself is usually encoded as a verb, and there's a verbal rule set for it. But anyway, that might be new, that's been merged. Instrument, companion. Companion is what I think was accompanier in AMR, but in AMR it could be inanimate things. In UR, it's just going to be animate entities. Materials, sources. Okay, we split source and start. I think it was just source in AMR. Now source is going to be if you have something that's been removed from a larger whole, like you cut the branch off the tree, plucked a flower from the bush. Whereas start is going to be the start point of like a motion event. So it's like a place. Goal, this used to be destination in AMR, but it's the same. It's a place. It's the opposite of start, I guess. Affectee, so in AMR we had beneficiary, but we also needed to capture maleficiaries. So she twisted his words against him. That's a maleficiary. So affectee is the parent term for both. Cause, manner. Cause has been split, so now we have reason. Sorry, I didn't get these examples filled in yet, but yeah, so that's been split. Reason is going to be like a mental motivation, like why did you do something, not just like cause and effect. They got married because they were in love. That was their motivation. Purpose is the same. Result is new. We agreed on that about the same time that we agreed on co-actor. So it's going to be resultatives. She worked her fingers raw. We were just using cause or the have cause 91 rule set for that, but it just got to where that felt really weird sometimes. So we have our own role for it. Temporal, extent, and other role. So I want to note other role in AMR we had mod. Well, we still have mod. Mod is a non-participant role, so mod can be used. It's kind of a catch-all role. But other role is it's also a catch-all role, but it's for the participant role. So if you have like a participant that feels really central to the event, but you don't feel like any of these roles fits it, go ahead and use other role rather than mod. Does that kind of make sense? Okay, does anybody have any more questions about any of those participant roles?
Do you have thoughts about the deciding about reification or not, or how you handle this process where the reified roles should sometimes appear?
Wait, what? Sorry.
Do you have any examples or comments about when you should use the reified role?
Yeah, so, okay, so I want to point out the website for the prop bank role sets, and I can put a link to this somewhere, but it's at verbs.colorado.edu, prop bank development. So we have all of the prop bank role sets in here, and if you type in like have actor here, so this will take you to all of these reification role sets. And there are examples in here that maybe are more helpful than what is going to be on this page. So basically, you're going to use the reification anytime that relation is actually predicated, like, like what I showed earlier with place. I mean, with place, it's pretty straightforward because in English, we express, he was in the classroom with a copula and then a prepositional phrase of location. We don't do that with all of the participant roles. Like, it's much harder to find an example of like an actor that's been predicated. So it's not impossible. You might encounter it more in some different language. The other thing is if you have a wonky like dialogue full of disfluencies, sometimes you'll have like one sentence will be kind of a fragment, and then the next sentence will just be a reference to a person. And like, you know that, well, they just threw this person's name out because they're the actor of the previous sentence proposition. I use the reification rule sets in that scenario sometimes, just because it helps to have the two argument slots for a co-reference later on.
Oh, interesting.
If that's the situation and it's not really being predicated, I just want the argument slots, I usually don't, I don't treat it as an event. So I don't give it aspect annotation, I don't give it modal strength annotation.
Okay,
Yeah.
thank you.
Hello. Sorry if I have missed it. How are the incorporated arguments annotated?
I'm sorry.
Incorporated arguments.
The incorporated arguments?
Yeah, part of the verb.
Wait, so can you give me an example?
The argument that's part of a verb, for example, like he is.
Sorry.
Okay.
Sorry.
The arguments that are part of a verb, for example, like he is long-legged or something like that.
Yeah. So he is long-legged, so that sentence would be predicating, so I would probably use the have mod role set, have mod 91 role set. So, and we'll talk about that some more later. But yeah, that would be an example of predicating, so I would use the verification. Sorry, my ears are bad. Okay, and then I just want to note, nope, that's still chronic. Where are we? Okay, I gotta go back. Nope, no, we're not done yet. Okay, I'm just gonna note that this slide exists. So this is actually a chart that is also in the guidelines, but it's really confusing and hard to read in the guidelines because of something about the way the table is formed. But basically, you've got like, it just kind of spells out for you that these are really central participants. These are going to be central to any event that they're a part of. And these are like circumstantial arguments. They're much less central to any event that they're a part of. I mean, sometimes these can actually be pretty central. And then also, we have different kinds of participant roles that tend to go with certain kinds of events. So change of state, you're going to have material and undergoer a lot. Motion, these are going to be the ones you use. Start more often than source usually. Transfer, you're going to have a recipient. And experiential, and this includes cognitive events like thinking, experience, or stimulus. So just that's for reference. And then also this is in here if you're interested in how the how the AMR roles map to the UMR roles. That is going to be in the slide deck. Okay, but now I'm going to go back to, not that, this one. Okay, so the non-participant roles, just know these are here. A lot of these are just directly the same as AMR. Direction, path, no, path is not new. Quantities, degree. Degree is actually going to be listed down below. But I put it up here because I always forget that it is now included under attributes, and then people like lose it and think that we don't have it. So we do have it. Duration, frequency, mod, once again, catch-all for less central things, like demonstratives, like I don't want to wear those shoes, that is going to be a mod. But it's also things like, the tall man, tall could be a mod. The other thing I want to note, just since I'm talking about it, so properties like the tall man, it is possible to have a role set for tall. In UMR, we are trying not to dictate to people whether you have to treat properties like that with a role set or not. You could choose to just use mod. You could choose to just use have mod, or you could build a role set.
How do you differentiate between participant and non-participant roles?
The good news is you don't really have to.
Here you are classifying the two sets. So what is the basis for classification?
It had to do with the centrality of the role, and I think it had to do with that classification typology work that Bill and his team did, but it was just when I was starting, and I don't know if it's published anywhere, but I remember Megan presenting, she'd done this big survey of roles in all of these different languages, semantic roles, and found the ones that tend to appear really frequently and tend to be central in some way that she had defined, and then those are the ones that ended up in that list.
Because I got curious because of this medium. So I called my mother on the phone. So it looks like very much called, and the participant is, if call is my verb, phone is very much required entity. So it is a participant. Why not?
Yeah, I think that's a good point. I think initially, people tend to say, well, participants are obligatory and non-participant are optional, but that's not quite true, right?
Right.
So they're not always obligatory. But in general, there is, for any given word, some of the rules tend to be essential.
Requirement, like to get the meaning of that verb.
Yeah, you
For
can have
example,
to have it, yes.
Yeah. A call,
Yeah.
somebody will be calling, something will be used for calling, and someone will be called.
Yes. So, things like time and location tend to be
Always there.
not very picky about which verbs they're co-occurring. But other things like the medium for particular type of verbs, and that's pretty essential, right? So that's when you create the ProBank frame files, that's what you consider, like which one's the core participants to each verb, and each sense of the verb. The different senses have different meanings. Yeah, so these are for languages that do not have a ProBank rule, so no numbered arguments. Formally, there is no distinction, but with the understanding that some of this is more central to a particular verb than others. But if you have a lexicon, and you usually define the core participants for each
But
one.
if we are planning to develop a lexicon from this annotation in future,
Then it becomes important, okay?
Yes, you can start with just giving them these names, and then later on say, well, these for this verb and this particular word is essential, right? And things. So this is like the two-stage process.
The other thing I'll note, and this also isn't a strict rule, but there are some roles that tend to just be arguments of verbs or predication. And then there are some roles that modify entities. They don't necessarily only modify entities, but like mod, it can be a modifier for an entity rather than an event. And I think medium is in that category. And that category of role tends to be down here in the non-persistent roles. So I think that's part of why it's there.
That example is form of bees. Bees would also be, because you say for set member relationships.
Mm-hmm.
So what would be the role for bees?
So let's see. So bees is
A member of swarm?
yeah. So the group relation is a set member relation. So A group B, A. Hold on.
R1 is bees, R1 is bees, R2 is swarm.
Yeah. Yeah.
Mm.
And this has been an interesting split. So in AMR we had consist of as a role, and we've split it into, I think some of them went into part, some of them went into group, some of them went into something else. Let's pick the third one. But yeah, it's been a little interesting to try to figure out how to fit into those categories.
Sorry. Instead of his shoes, if we use, for example, his calling, without control relationship, is it still a possessor-possessee relationship? Or?
The possessor. Sorry.
If we put in place of shoes, it's verbal now. He's
Yeah.
calling.
Uh-huh.
He's being called, maybe.
So if
there is no control of him over calling. So it's control relationship,
So the temporary control there means, it doesn't have to mean like ownership, like with a title or a deed. You can just like, if someone loans you something, or it's that kind of temporary control. Is that what you're asking?
Okay, but when we say he's calling, or he's being called,
His calling or his being called.
yeah, the control is the other way.
Yeah, so in that case, I actually wouldn't use the possessor. I would use the participant roles that would relate to the calling event. So his calling on the phone, because that's the sense you mean, right? I would be like an actor or recipient, I guess, if he's receiving a call. Yeah, does that?
Yeah.
Okay.
Thank you.
Okay. Okay, so here's ORD. I do want to note range start and range trajectory. Those were introduced in spatial AMR, but they are not strictly spatial roles. They're actually applicable, especially range start. They're applicable for temporal situations as well. Anytime you are counting an ordinal, like you start counting somewhere. So the third block from the left-hand side, that one is range start. So the left-hand side is the start point of your counting. And then the second chair towards the front, that's actually just the direction that you're counting. So that's how you would use those. List item, lists of things. Okay, so those are all the non-participant roles. These are the spatial roles that we've agreed we can use. They're all roles that were used in the Minecraft dialogue corpus. We do in English have some role sets for colors. If you have a role set for something, but there's also a way to handle it like this, you can really choose for your language how you want to do it. if you have a rule set, you can go ahead and use it. Sometimes they're more informative. They let you do sentence disambiguation. Yeah, so don't feel like anything that's a color, you have to use the color rule. And then I won't go into detail with these because, yeah, but just know they're available. If you're doing something grounded or fine-grained with spatial frame of reference, they're there. Okay, so here are the attribute roles. These are the ones that have a fixed set of constant values to choose from. Politeness, I did not come up with a rudeness construction, but theoretically you could have a rude comment that you would put a polite negative on. Polarity. Shira, what did we decide for the double negation? I feel like I actually went and looked at our paper and I was like, crap, I can't find it written down anywhere. So this might not be what we decided, but
I will let you know.
used it? Okay. Well, this would work. Something will go there. Some languages have double negation, and it's nice to be able to annotate it. It would have been, the problem is with a negative sign or a plus sign, you don't have a variable for it. So you can't add like a degree intensifier to it, which would have been nice. But yeah, if you want to mark double negation, there's a good way to do it. Polarity is an interesting one because it can take these symbols or it can take these concepts. So truth value, this would be for like weather constructions. I don't know if I have any money. The graph would be, no, the pop-ups don't work. Okay.
Maybe you should just update.
No, you know what? Okay, here, I'm gonna try this one. Wait, what?
I'm going to quickly mention, we say that one idea is to modify the polarity with role degree intensifier.
Yeah, so I think we were talking about making, we were talking about changing it in the UMR writer so that it would actually generate a variable for the negative sign.
Oh, yeah.
But I'm not sure if that got implemented or not. Okay, I also have these pages on my site, so let's see if it works here. Or maybe I just didn't make examples. I didn't make the examples. Okay. Well, okay. What?
Is it somehow the backup version of the homepage, or is it because you just changed? Am I right? This is not from the home.
This is like the page, my GitHub page where I was testing it out.
Oh, okay.
And then it got put on the UMR page, and I wasn't the one who put it on the UMR page. So it's basically just like this. So like, here's your event, and then you would have polarity would be truth value. It's okay. So the head node is going to be truth value, and then it would be polarity of, and then the second event. So I don't know if, what is the sentence? I have any shoes or something? Where did it go? I don't know if I have any money. Yeah. I don't know if I have any money. That's what it looks like. Every once in a while, you might get a chance to use polarity positive. I have had to use it a few times in discourse. Sometimes it's handy, not discourse, in dialogues. Sometimes it is handy to use it, so just know that exists. Yes or no questions use UMR unknown. So you just put that into the argument that is unknown. So, do you have any money? No, hold on. Sorry, I'm talking about content questions. For yes or no questions, when it's just under polarity. Do you have any money? It's just polarity UMR unknown. Same as AMR. We've just replaced AMR with UMR. Mode, same as AMR. 3 types, interrogative, imperative, expressive. And then degree, so we have done a slightly new thing with degree. And there are actually 2 different degree reifications. So this one, half degree 91, this is used for like comparative constructions, superlative constructions, and like sufficiency, like enough to such and such. But this role, you can still annotate the way that you would have in UMR. So woman is highly intelligent. You can still put degree high with the concept from the sentence if you want to. But you could also say you don't want to put that word in the graph, and you could just put intensifier, the constant value. So there's two options for degree. And so yeah, downtoner is the numbers. Intensifier, downtoner, and equal. I couldn't find any examples of equal in our release data. I feel like this is not the example that this is supposed to go down below. I didn't have an example for equal. This should go down here. So some concept just means that you want to actually put the word from the sentence into the role. Okay, here are the pronoun lattices. So different languages obviously arrange their pronouns differently, mark different things. I want to just say up front, you don't have any way to encode gender, which feels crazy to everybody. It's just that it's a really big can of worms, and we just haven't opened it. So no gender, but you can't just divide everything into first, second, and third for all languages. Some languages don't have those. So these are the options that you've got. You've also got, if you want to get fine grained with inclusive and exclusive, you can, but you don't have to. That's the whole point of the lattice. The refer number is same deal, and I have definitions for all of these things down below. Although I don't have examples for them because I need examples from other languages. So if anyone is working with languages that do any of these other kinds of number types, send me examples. And then here is an example of the new referred definiteness. So one does not simply walk into Mordor. And we decided if you have a generic pronoun like this, you can still mark the person, but it's weird to also mark the number. So don't mark number, just mark the definiteness. Okay, any questions about any of those roles? Okay. Okay, do we want to try some? All right. So just yellow. Okay, so he ran up the hill. What roles do you think they might be?
So will run up be one verb, or are we doing phrasal verb in a different way?
Oh, I'm sorry. So we'll put a label on he, and we'll put a label on up the hill. And you don't have to, it's just for the purpose of this example. You could treat up differently if you wanted to. All right, I'll just jump in there. So he ran, okay, so he, in this case, he's going to be the actor. He's acting volitionally. And up the hill is a direction in this case. Even though a goal is mentioned, it's not certain that he's gotten there, it's just the direction that he's running. He ran his dog up the hill.
He's the cause.
Yes. I think
The dog is running.
so. That's a really good question, actually. I think it would be causer. Hold on.
What did she say? He is. She is.
I'm gonna look. Okay, in here in the guidelines, there's a table of verb meanings where they've tried to make some consistent decisions. So run, the runner is the actor. And I think that means that the causer is probably the causer. So he's probably the causer and the dog is probably the actor.
what will be the verb? It cannot be, the two run cannot be same sense verb. Actually here ran means make run. If we make he the causer, then the two senses of run should be different. Even though lexically they look same.
So yes, that is a really good point, and it's different from language to language. So UMR has decided that if you have those two meanings and they're combined into a single verb, you can still just use a single node. You don't have to split the causation out into its own node, but you do still need the causal role. It's weird though, right? Because they're both running. But in this case, that's just part of what's encoded lexically in that run rule set. So with the actual run rule set, there are actually arguments for both the causer and a potential entity that is being caused to run.
I think it's a question that is your question that because there's a cause in the second sentence and those two should be different senses as well, right?
Oh, that this run and this run should be different senses?
Yeah, because the second run is make somebody run.
Yeah. So, okay, I see what you're saying now. So that is a way that you could do it. In English, so run is obviously a really frequent word, and when English prop ink was being built, especially in the beginning, it was very coarse-grained. So that was the kind of thing that was, the two microsenses were put together into a single sense, and it was decided that one of the arguments was just optional.
Yeah, so I think so one of the initial motivations for this sort of thing is that there is alternations, right? Like break the window and the window broke, right? So the stone broke the window broke. So the idea is that those two breaks actually have the same sense. It's just that in one of the frames it has more arguments. So that's different
No,
from.
as soon as I have more arguments, the sense changes.
And that's valid.
And like if I translate it in our like in Indian languages, I will use a different verb.
It is a different verb, yes.
I will use do run, yeah, make run.
I think that just means that these alternations are not universal, right? So
Yeah.
So for English languages, I think because adding a cause is such a general process. So just doing that does not change the meaning of that word for
If you have
English.
eat and feed, you will definitely have two different sense, right?
Oh, they're different words.
Yeah,
right.
Yeah, when you see different words, you make them different. When you see same word, you don't.
Yeah, and
It's
that's,
semantically.
yeah, that's part of what's so tricky about trying to make a uniform representation though, and that's part of why we're trying to separate out consistency in just the general UMR schema and then allow the lexicon side to be more specific to the language. So if you want to make two separate rule sets, make two separate rule sets. But if you want to lump them together for whatever reason, then you can also do that. I mean, it's up to you how to build the lexicon.
When we sorry.
No, go ahead.
See, when we talk about lexicon, we talk about words. But when we are talking about UMR, we are talking about concept. And concept and lexicon words need not be one-to-one.
Right.
So the decision that we take for making lexicon may not always work for concept specification in UM, or for that matter, any meaning representation.
Yeah, and when I'm saying lexicon here, I'm using it very specifically. It's valency lexicon, and this question of what is a word and what does it mean to be a word in UMR, especially. It's been breaking my brain for the last couple of years. So, I mean lexicon in that very specific sense, not in this is a white space defined word. The other thing that I just wanted to note is that the prop bank rule sets were built inspired on VerbNet, and VerbNet has a single class that includes both of those senses. So I'll just show you the class real quick. So the horse ran. This is the semantic representation for that. There's just a single predicate. It's an activity. That's what the umlaut means. You've got the theme who's doing the running, and you've got a trajectory. And then, if you go down to these sub-senses, hold on, that is... Okay, so this subclass here, this is the one that adds an agent. So Tom jumped the horse over the fence. If you look at this semantic representation, this is exactly what you're talking about. You've got multiple parties who are both doing their own running. They both have their own start and end points, even though they're probably co-referential. And you have causation in there. I mean, yeah. So you can see, like, they really are very different. It's just when it came to building the cropping rule set, they lumped it together. So, okay. Oop. Okay, Max argued with Jerry. I think this one is probably a good actor, co-actor. Yeah. Jerry wrote a play. Actor and theme. Max coughed during the intro. Wait, what?
Temporal.
Yeah, temporal for during the intro. What about Max? Is coughing, was coughing this? I could see it being an I could see it being a theme or an actor. The guidelines have it down as an actor, so that's the direction that we've fallen in UMR, I guess. Oops, I keep trying to scroll. Jerry shaved his mustache. So this one I think is going to be an actor and a theme. Jerry shaved his face. His face is going to be an undergoer. Jerry shaved his mustache off his face. This is going to turn into a source. So it's interesting to me how the roles can kind of influence each other, even if it's really the same event that you're talking about and the same participants that you're talking about. Susan was overjoyed at the performance. Classic experience or stimulus. Vanessa knows the lead actor. Also experience or stimulus. He tied his dog to the railing outside. This is one where you could kind of go a couple different directions. If we had a co-theme role, you could consider the railing and the dog to be two things that are tied together symmetrically. But UMR has chosen to call this a goal. So theme and goal. He carved the wood. It would be a material. He carved his name into the railing. Probably going to be a theme and a goal. And he taught his dog to shake hands. Now there was some argument for a little while about whether we needed a different role for like complement clauses, but we just decided it was ridiculous and that they're going to be theme. So theme it is.
Sorry, once again, please, about he carved the wood.
So he carved the wood. It will be an actor and a material.
It's different from the theme.
Yeah, but there's overlap, right?
Yeah.
He carved the wood into something, we can say that, right?
Mm-hmm.
So what is coming out of it is the
Yeah.
and that's
Yeah.
why wood is the material.
It's also kind of an undergoer too. I mean, the wood is undergoing a change, so yeah. So there really is an overlap between the roles, and that's why that table in the guidelines is handy, because it just helps keep track of what conventions have been adopted. Okay, so let's see. So that's the end of talking about the roles until we get to aspect and modal strength, which we will talk about at the end, because when I'm annotating, it's probably because I'm an old AMR person, but I don't usually, when I was starting UMR, I didn't bother with the aspect and the modal strength until a second pass. So if you want to do it that way, it's reasonable. Okay, so basic concepts. So remember before we had graph structures. So you could have a graph concept that was actually the like text that you would put into the graph. This is the semantic concept. So this is like the referent in the real world or whatever. So basic entities are, like participants, entities in the world. Pronouns we've looked at already. Named entities we've looked at already. And abstract concepts, we've seen some examples of them, but there's a page on the website where you can actually see all of the different abstract concepts that UMR provides. And then same with predicates. So mostly you're going to be getting predicates from your role set lexicon if you have a role set lexicon, or from words in the sentence that you're going to put a dash, 0, 0 on. But there are also abstract role sets. And the abstract role sets do include the reification role sets, which we've already talked about, but there are others. So now,
Sorry, Julia.
Yeah.
What about temporal relations? Where do they fit there?
temporal relations are marked at both the sentence level and also the document level. So like he walked his dog today is going to fall under a temporal relation. I think temporal is a non-participant role. So,
Okay, so but if we have two sentences and we want to establish the relation between them?
yeah, so that'll be in the document level graph.
Oh, okay.
Yes, we'll talk about that later. Okay, so the named entities, let's look at the named entities first. So we have updated the named entity hierarchy. The English AMR hierarchy was great. There were holes in it, but also it's very Western culture centric. So there was a lot of effort that went into trying to come up with categories that were just more inclusive of non-Western cultures. It is a bigger hierarchy. It went from like 70 types to like 180 or something like that. I don't have examples in here yet. There is a document that has definitions for these things that I can share to the UMR folder. But yeah, just so these are all the types that are in there. See if there are any particular ones I want to note. Nationality, there's like only one instance in all of the history of AMR. I mean, I don't know, we've talked about taking it out, but social groups, we've redone these, and keep in mind you can use any of these parent types. Like you can go as generic as you want. You can use thing, or you can go as fine-grained as you want. And there is also a website that shows the mappings from the AMR named entity types to the UMR named entity types if anybody is interested in that. I'm just going to scroll through these. They just range from vague to specific. We've added a city square. It's a new one. Historical period. I don't have examples here, but that would be like different. Yeah, dynasties. Yeah, dynasties.
So do you have their event? So for aspect, you don't use event state? The distinction?
Oh, so actually no, we don't have a type called event in aspect. But if we did, it would be different in the graph because these are all going to be like concepts with a variable, and they'll all have a name role following them. You can also use event as if you have like just a generic slot you need to fill in your graph for co-reference later on. There's an example of that in the pronouns. Let me show you. Okay, so, no, where was it? I thought it was in there. Okay, I don't know where it is, I'll find it. There are cases where the pronoun, can be talking about an event, and you can actually use event as the head for a pronoun. What were we looking at? We were looking at the named entity hierarchy. Okay.
you said that it can be an event, co-referred to another event. So in terms of the attributes of aspect, would you add the same attribute, the spectral class of the event? No?
No. Oh, that sounds awful. No, if it's a pronoun, then it's co-referring to something that has hopefully already been introduced, and you're going to link those two things together, so you really don't have to put in any of that extra aspectual information, because it's going to inherit it from the first time it was mentioned. So that's the out.
Okay.
Okay, so we're down by event. Cultural activity and cultural artifact, those are new. They have been, some of these were concepts that were in the AMR types, but they've been reorganized a bit. We've added some computer-related stuff. Vehicles, we've expanded. Qualifications, like degrees, tests, like the SATs, honors, like awards. Government output, so I think we already had like tax and social program, and legislation maybe, but yeah, we've added a few there. Systems, we've added a lot to. Biomedical is mostly the same. And then these ones, category and conceptualization. There are actually a bunch of subtypes that we thought about adding under there. I mean, if you are doing some kind of corpus where you really want to get fine-grained with like what's a strategy and what's a theorem, you could expand this into the kind of things. But we've just lumped them together currently. But this was something that was missing in AMR, and it always drove me crazy, like the kind of like conceptual stuff. Okay, so those are the named entity types. Everything else about the named entity annotation is the same as in AMR, other than that you don't have to do wiki if you don't want to. Those, I was going to make some more sentences, and then I did not. Okay, let's look at the abstract concepts. Oh, here it is. Okay. It has no bearing on our workforce today. So the annotator has decided that this it is an event. So rather than just putting the thing, which is what we probably would have done in AMR, you can actually put event. My dog came up to me, he said, "Rawr." The dog is an animal. Now, in a lot of my Arapaho stories, you have animals who are personified a lot, and so I call them person if they're characters who are speaking and interacting. Gods would be person, but if it's just like, I don't know, maybe your dog is a person. You could call your dog person if you want. Anyway, animal is new, you can use it for pronouns. It tasted mealy, just a general thing. So the other thing I want to note about these, okay, so in multi-sentence AMR, there was this nice post-processing step. You would annotate your sentence with what was explicitly listed in the sentence. And then in post-processing, they would go through and all numbered arguments associated with your role set that hadn't been used, they would be added back into the graph as an implicit argument that you could use for co-reference. Well, we don't have a step like that in UMR, partly because if you don't have role sets, you can't predict what arguments are not mentioned. That has been tricky because it means when you're doing the sentence level annotation, if you know you're going to have co-reference with some unmentioned entity in your sentence, you have to think ahead and you have to actually add a stub for it in the graph. And it is kind of hard to do that consistently, although the more you do it, I think people kind of come together and do it okay. It's really tricky too when you have different languages who incorporate nouns differently. I mean, where are the boundaries on when you add these implicit arguments? It's still, yeah, it's interesting. But anyway, so if you want to add a node into your graph for an implicit argument, you can use these concepts. You can use concepts from the named entity hierarchy. You can also use concepts that are like the name of a role. I'm here at work again. So because we're talking about work as in like the location, but it's useful to be able to connect that back to the verb work and say it's the place where you work. But you need something, you need a concept there to be the head node to link back to work. So I use place. AMR might have used name, but sometimes it's just more informative to use place or temporal or quantity. So just know that those things are allowed if you're adding implicit arguments. Yeah, so there's an example of quantity. Yeah, this is from the UMR 2.0 release. Yeah, a number that was higher than expected. Here in one place is how we handle questions, options, and meta-labeling. So UMR unknown, we talked about it with polarity already. Oh, I guess I should add that here. But so we talked about it with yes or no questions, but here's an example of how you do it with a content question. So who put the cookie in the cookie jar? The person, the R0 of the put, you just add the UMR unknown into that slot in their place. Truth value, we already talked about. UMR choice, this is like options. Would you like coffee or tea? So it takes 2 little op arguments, or more if you have multiple options. UMR empty, if there's no text in your sentence and you have to put something in so that your parser doesn't break, put UMR empty. UMR unintelligible, if it's just gibberish, that's what you put. Okay, so we have several entity types. You can see there are just all kinds of things. There are like mathematical things, emoticons. Most of them take a value subrole. Some of them take ops, however many numbers of ops. Date entity is probably the most important one. So it takes all of these possible subroles. You obviously don't have to fill all of them in, but yeah, like the academic year, you would, hold on. Yeah, okay, no, that's right. Yeah, so that academic year, that's the calendar that's being used. Century, you just put a number. Should that be 18 or should that be 1800? I think you, probably 18. Dates, you also put the number. Months, you use the number, unless you're using a calendar that doesn't number their months, then you can put a concept. Eras, decades, day periods, quarters, yeah, so. Oh, and then year 2, everybody says, what's year 2? It's like this. So if you have a span of years, then you can have a single date entity with 2 different years in it. String entity is interesting. This one came up a fair amount in Minecraft data. So if you're talking about the word itself rather than the referent of the word, you can use string entity. And like in the spatial data, they would use like an equal sign to show you what the shape was that they were building. And so in that case, like the meaning of equals had nothing to do with the dialogue. So I would use string entity, like they're really referring to the symbol. String entity. You can also use it. Oh, I lost it. Is that the case where you can use it? I don't know. It'll come back to me. Ordinals we already talked about. URLs, percentages, phone numbers, email addresses, value intervals. Please read pages 320 to 325. They're just, refer to this list. There are all kinds of things in here. Very useful. Quantities, we have all these quantity types. So there are a lot of them. Most of them I have never used before. This list of suggested values, they're just suggested values. You can have other units in there too, but these are common ones. The only ones that are different, they all have a quant and they all have a unit. Acidity quantity, seismic quantity, and temperature quantity. seismic quantities in there twice. They all have a scale argument also. So with temperature, oh no, I didn't put examples in. So with temperature, that would be like, 10 degrees Fahrenheit. So Fahrenheit would be the scale, 10 would be the quant, and degree would be the unit. Spatial entities, we don't need to go over these. Some of these are still under development. If you have more questions about spatial, I'm happy to answer it. What time? Oh, we have 15 minutes before lunch? Okay. Okay, one quick note. So we talked about the group role earlier. Like a swarm of bees. That one is borderline for me with the mensural quantity. So like one glass of water or one ball of cheese. So you've got a unit and you've got a quantity, but you'll actually put the thing that is in that unit. As a head node, you'll put the unit of the ball of cheese. You'll do it like this. There are cases where you don't have this and all you have is the unit. I don't know, they get a little weird. Let's not talk about that. Quantification and scope, I wish James was still in here. I have done very little with this, and the section in the guidelines is very short. We do have this scope concept, so if you're working on a corpus where you really want to get into detail about your scope and your quantification, you can use this. I think the general consensus is that there are standard interpretations for scopal phrases, like 3 people moved a piano. Your standard interpretation is going to be that there was one piano that was moved and that 3 people moved that one piano. Not that 3 people each moved their own piano. So if it's a straightforward interpretation of the scope, you can leave it unannotated. If you have a really unusual interpretation, then you can go ahead and use the scope concept. Do you have anything else you want to say about scope? Are you more familiar with it than I am?
No, I think that's pretty much it. There's a section of guidelines. So there's a default scope, and people can just go with that. Because once you allocate every scope, it's just going to be very crowded, very messy.
Okay, the abstract rule sets. Back to here. Okay, so there are a variety of reasons that you might have abstract rule sets. A lot of times, it doesn't mean that there's predication happening. It just means that you have some kind of concept that has multiple fixed arguments associated with it. So like by line 91, that's if you have this, if you're annotating like a newspaper document and it has this line at the top that's part of it, and it says, who the news organization is, who the author is, like it just gives you a nice way to annotate it. Correlate 91, that is a nice construction rule set. We need more construction rule sets. This one is fun because the X or the wire construction, it actually appears quite often cross-linguistically. So it's nice that we got to include that as a general rule set for UMR. But yeah, so it looks like this. So this is a schematic construction. You've got 2 slots. You've got, the first thing and the second thing. And then each one is going to have a half degree 91 relationship. Well, I guess that one's half degree. Yeah. Courses, distribution ranges. These ones are new, but I don't remember if we had them last summer. Emit sound. So this was from the first UMR release, actually. Like onomatopoeias. So in this case, this person is, they're watching the Pair Story video, which is used in a lot of language documentation projects. So they're describing what they're seeing in this soundless video. Where they're actually saying like, oh yeah, like the kid's got this paddle ball thing, like what do you call it? Chong, 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 chong. So when you do the document level graph, this first sentence, you've got the paddle ball. You can actually link paddle ball to the thing making the sound in this roll set. So it's just nice because it gives you the thing that's making the sound and it also gives you a space for this actual onomatopoeia. Same thing with gesture. So this is what this transcription looked like. They had the gestures that were being made in some cases actually written into the transcription. There was one where he does a brush off gesture too. So this, we're going to have a different layer for the actual gesture annotation. This is not the full gesture annotation. This is just a case where this gesture is actually filling an argument slot for this verb. I mean, that's what he's doing. He's doing this gesture. So it's nice to have a way to actually incorporate that gesture into the graph. Hyperlinks. Include 91 is really frequently used. You've got a subset, a superset, and relative size. Inferences. That one's a mean 91. So in AMR we used mean 01, which was an English roll set. There are a lot of cases like that where AMR used an English roll set for some abstract purpose for inferred relations. And we've changed all of those to like a generic -91 roll set now. So like perp equals purple. Oh yeah, this is the other case where you would use a string entity. So perp was a misspelling in the previous sentence. So this guy is just correcting himself. Perp equals purple. This string entity was actually supposed to say purple, and that is the meaning of purple. So I did the string entity for the first argument, but not for the second one, because the second one, you're still like, you actually want the meaning of it, rather than just the string. Proverbs. These are fun. So the mountains are high and the emperor is far away. These are cases where the line, and we'll talk more about multi-word expressions tomorrow, but there's a line between an idiom and a proverb. An idiom is probably shorter, and you can kind of get away with not decomposing it fully. Whereas this is an entire, it's like a whole sentence, and the sentence is fixed. And you don't want to just hyphenate that whole thing into a single node. Like that would be crazy. It's better to be able to decompose it into a fully grammar graph. But you still want to indicate that it's a proverb. So, but the reason there are two arguments for proverb are things like this, and also I don't remember what they're called in Chinese, but it's a common kind of proverb in Chinese, right? Where you have the first phrase and then you have a second phrase that like gives you more information about how to interpret the first phrase. But yeah, very much like life is like a box of chocolates. You never know what you're going to get.
Yes.
Publication is great for references. We've added some things to it. We added a URL argument. Is that all we added to it? Maybe that's all we added to it. Yeah, okay. Weather. Weather is new. We have rule sets for all the weather verbs in English, generally, but not all languages do. Not all languages are going to treat them as verbs either, so sometimes it's useful to have this. And then there are a couple spatial rule sets that you'll see in the UMR 2.0 release, although these have been updated compared to what's in that, so this is going to look different. But this is what I think the final rule sets are going to look like. Okay, we're ready to talk about aspect. We have 7 minutes.
You're using number 91.
Mhm.
Does it mean something, or is it just not default? Just to not understand. I'm sorry.
No, it's a good question, and I don't know. I don't know the answer. Why, they settled on 91, it was an AMR convention.
Yeah, I think it's just something inherited from EMR. So usually, like, we have word senses for each word, right? So they have, number 1, number 2, number 3. So we need something for a sense that's never going to be an actual sense. So they make it a very large number, which 91. So no word will have more than
91, yes,
Yeah.
this, just I thought that maybe it's somehow behind hidden info what you, I don't know.
There is no hidden info other than the fact that it's going to be an abstract word, abstract concept.
Yeah, we just kept -91 because that was what AMR users were already kind of used to. But I don't know why it was 91 and not 99.
Yeah,
You know?
we'll be
No,
fine.
just I thought that okay, what is that?
Yeah.
Yeah, that part of the history you can under.
Okay, well, since we only have like 5 minutes left, here's what I'm gonna do. So we've still got the aspect to talk about. We've got the modal roles to talk about. The conversation about what's an event in UMR is much less complicated than it used to be because we finally figured out what was wrong with it. And then a couple special notes about annotating discourse. And that was it for this slideshow, so we're really close. If you want to look at aspect, okay, where's non-prototypical predication? I think we didn't do that yet either. Okay. If you want to look at aspect, we've still, okay, it's there. So we've got a nice lattice there. You can look at all the types, and then there are definitions of all the types down here. If you want to peruse it this evening when we're in the rain at the barbecue, nobody will do that. There's also non-prototypical predication, which we haven't talked about yet. So this is like copula, juxtaposition. It's actually, we'll spend a little time on that tomorrow. And then discourse relations. So those are the things that we haven't covered yet.
About aspect and, for instance, discourse relation, what is the basis, the theoretical basis for the different texts that you choose?
For the types?
Yes.
So I think it was Bill's team who settled on these types. The aspect types, yeah.
Because I see there, for instance, performance. It's not very common to see in spectral taxonomies.
Performance?
Yeah.
Yeah, it's, so the thing is, aspect is encoded in so many different ways grammatically, and then it's also analyzed in so many different ways conceptually, and trying to find a set of types that are going to fit the grammatical categories that all languages have and also satisfy all these, the other ways of analyzing it. It's a very tough project. I mean, you know how it is with aspects, like the labels that they use, everybody who uses these terms has to redefine them because they're using them in a slightly different way from the last person. So reading the definitions carefully is an important process. This is actually what most people would refer to as a vent. It trips me up because I'm used to thinking of process as an activity, But yeah, just like with the rest of the lattices, the idea is you've got really broad categories at the top and you've got really fine-grained categories at the bottom. Generic is new. The other ones that are new are iterative, and then inceptive, which I snuck in there, and I have not gotten permission yet. So we'll talk about why I snuck that in there tomorrow.
So I guess one thing that is a bit unusual from the standard thing that people use in like achievement and accomplishment.
Yes.
So it makes no difference. It does not make that distinction, achievement and accomplishment. But instead, it makes the distinction between performance and endeavor, which is performance is something that's actually completed, and endeavor is something that's kind of like stopped. We didn't actually finish, like go to its natural endpoint. So I guess the reason there is because sometimes it's difficult to make the distinction between accomplishment and achievement. So that's kind of deals with the discovery of it. So that's a key. That's maybe a key kind of like a difference between just what the standard is doing. The other things like generic habitual linearness. So those are generally distinct from the aspect. But they added here because you have to deal with them in an annotation.
So here we are annotating aspect as it has been specified in the sentence and not lexical aspect.
Not lexical aspect. Yes.
Right.
That's
Yeah.
Accomplishment.
Grammatic.
the,
So endeavor, yeah, what is the word performer? Here it is being used as performance, I think. They are actually lexical aspect. When it is being used in the